welcome to Engineering Marvels. And today we are going to Truss problem. It's a 2D problem using finite element method with the help of ABAQUS. This problem, the system is exposed to 4 different types of loading. Not different type, in fact, they are different in magnitude and maybe in direction. 15 kilonewton H nodes in the positive x direction, while in the negative direction H nodes 3, 4 and 7. The corresponding geometry is being shown here in the picture. The horizontal elements have cross-sectional area 0.045 square meter, while diagonal have cross-sectional area 0.02 square meter. They are made of same material, which is a good news for us and make the problem even simpler. The Young's modulus for both is 30 multiplied 10 raised to the power 6 kilonewton per square meter. And these sort of problems, we are interested in the stresses that are carried by each and every element, and also the deformation they are exposed to. So now switching to ABAQUS. Well, I have installed 6.14 version, so you can have any ones. This one is the latest one, I think, but it doesn't matter. So I'll create a model database. I go to click on standard explicit model. Now the first thing you need to do is go to file and set working directory. Well, I have already here selected Truss. It's a folder. You can have it on any drive, it doesn't matter. Well, so the C drive is not a best option, but it's temporary. So click on OK. I go again to File and Save As. I'm going to save as. I call it Truss problem.cre and CAE format. Make sure. Okay, yeah, so we finished with this. The next thing we need to do is to create the geometry. So either double click on part or right click and select create a part. It's the same thing. And I call this Truss part. Make sure it's a 2D planar and type is deformable, feature is wire. And approximate size 10 is, I think 10 meters is more than enough. Okay, that's what it appears then. And pick there for line creations. Here, moving the cursor, it shows the right left top corner where we can see the corresponding x and y coordinates or the location of my cursor. So click at the origin, and from here either click on other point or you can type in from keyboard. If I say 2, 0, it means in the x direction 2 while in the y direction 0. And then I enter 1, 2, which means 1 meter in the x direction, 2 meter in the y directions. Click on enter, and okay, that's what we got. And you can zoom it out, zoom in and zoom it out. So the next thing I want to do is to get similar structures of sections, which I can do by using the pattern command. You click on pattern, then select the geometry, say done, and here you see a pop-up window. Here select 4. In the x direction we need 4 numbers, while spacing between them is 2 meter, and the y direction we need only 1 pattern. I click on OK, and then comes to the fit and wave window. Here I go to the line section and creation, and I join these top edges. Press escape to get out of the line command. So we have almost finished with the geometry, I think. Then click on done. Okay, the geometry is finished. Now it comes to apply type of materials. Double click on it. Is it a single material? So I'll say truss material. Go to mechanical for some properties, and the most important of many properties is the Young's modulus, which we have given already here as 30 10 raised to the power 6. So 30e6. Young Poisson ratio is not necessarily, but for these sort of problems doesn't matter even if you enter it here. Okay, materials I specified. Now we need the next thing is the section creations. There are 2 different sections. We can see here in the problem section 1 and 2 with the different cross-sectional areas. So right click, say create it. The first section I want to say is longitudinal. So it's beam, and click on truss. The cross-sectional area which I'm given there 0.045 square meter. Okay, as you can see here. Also for the diagonal elements is 0.02, and the next section that I'm interested in is the diagonal. Okay, so again, same beam and truss. Well, here the cross-sectional area is even smaller. It's only 20 centimeter. Sorry. What happens? That's okay. And once we define the sections, the next step is go to expand the truss parts and locate section assignment. Right click and say create. Here we're going to assign the sections. You press down the shift key, and for multi selections, the longitudinal first, you can select diagonal first, doesn't matter again. Click on done, and there is our longitudinal. So okay, we need to assign one more section, which is obviously the diagonal. So again, done, and the name given is diagonal. Okay, we are almost finished with section 2, section assignments. And the next step for sure is the meshing. So double click on meshing. Go to mesh and search for element type. Select the whole structure and click on done. So elements library, so it's not a complex structure. We don't need what type of elements or the cells they are meshing with it. So standard, linear, and here select the truss that we are looking for. Click on OK, and then go to C. Click on edges, select the structure, so it will find out the edges of this system, or the combination of the elements. We need only at the nodes, so click the number of elements that we want. If I say 2, so I can see the effects. It gave me, in fact, 3 points on a single element. I need only at nodes. Click on 1 and then apply it. You can see here we selected the edges. Okay, so we're done with, and then go to click on done. I should know that we are finished with. Go to mesh again, say part, and accept it. Yes, mesh is complete. Color changed. This is the indication that we have done successfully the meshing part. And the next thing is to assemble if there are more than one part. But as we have only one part, we don't need to assemble anything. You can assemble, then go to instances and there. So you don't have too much parts, only one. Click on OK. Then it comes to the most important section of the problem. This is the boundary basis. Go to steps and expand the initials and locate the boundary. Double click on it. Well, there are two types of boundary conditions. I can say here it's the pen support. It can't move in any direction out of X, Y, Z. While this is a roller support, it can move in the X directions pretty freely. Okay, so this is the time now to specify both of them. I say pen support. Okay, and write down the name so that we should recognize it by its name. Make sure it's symmetry and symmetry, and activate the mechanical. Click on OK, and then let's say that select the region or the corner where we have boundary located, and click on done. Here the option we're going to select is panned. This tells me that we can't move due to this restriction in the X, Y, and Z directions. There is 0. Though it can rotate, the structure can rotate. To keep it from rotations, we need the next boundary condition, which is roller type. For this, I go again to boundary conditions, create. This time I named it roller support. Okay, and select it. Say done. There you need to click on this one. Its symmetry tells me that we can't move in the Y and Z direction, but it's free to move in the X direction, and also can't rotate along about the axis. Okay. And I think we have finished with the boundary conditions. Then we need to apply the loads. So we go to step and create there to apply load. Okay, to make sure it's static and general, and we don't need to make any editing in this menu. Okay, we got here apply load. So There are different load we have here for different 4 locations. So all of them should be described now in a different way. It's node 2 i15. Its name. It's computer don't know that it's 15 now. Right now, just for our understanding, is on this age. Say done. This is what computer wants to know. It's 15 in the x direction, positive directions. Okay, and create one more. So it's repeat 4 times. It's node 3. We have 7 or 5, I think. Yeah, 5 kilonewton. Okay. Say done. Sorry, you select the age of this one. Yeah, and it's minus 5 kilonewton. And then 1 more, oh, 2 more time. Wait, oh god. Node. I think it's 4, node 4, and it's 7 kilonewton. Click on continue. This one, yeah. Make sure it's in the negative y direction, CF2. 1 more time. Be patient there. And it's node 7 if I'm not wrong. Doesn't matter. For our own understanding, I'm doing so. Labeling and this sort. It's minus 10 kilonewton in the y direction. Negative y directions. Okay, I think we have also finished with load applications. Once you applied all the loads, and then comes the last step. That's analysis. Like, go to jobs and create it. I must simply say, come on, man, it's a Truss problems. May have problems with name indications if you do not rename it. So you leave it as it is. The job type is full analysis. We need a bit around this and immediately. Okay. And then expand the job. There is your Truss problems. Submit it. Once you submit it, it's not the real task of the computer. It's gonna solve now for you. It'll take a little while. Be patient again. And might take 30 or 40 seconds in this case. Depending on how simple your geometry problem is. It's not running now. You can see the message. Then you say, it's giving me a message what's happening at the bigger rounds. So I'll be into files where we are now. And it's analyzing for us. Complete processor. Okay. So the simulation is completed. And now all we have to do is to right click and check out the results. This is the most interesting part. Go to the deformed shape. And we can see here, these 2 elements, I'm sorry, they are under most stresses. Well, these 2 seems to be least on the least stress. So this might need a replacement, and this is the stress configuration. While we can see the deformed results, which tells us that the elements that are far away from supports will be under high stresses. Oh, sorry, I mean under high deformation. While those it's close to supports will be under least deformation. So this kind of nice, very nice. And one more thing that I want to say is the animation. Look at this. Isn't that pretty? This looks so nice. You can make it adaptable. Look, click it on the frame selector and just move it forth and back, and you can absorb. Oh, you might feel it too. Look at that. Beautiful, isn't that? Well, I hope you have enjoyed that. Thanks for watching.